This is the key to worksheet 4.2 part 2. And in number 1, you want to find the domain of each log function. So you got to remember that if you look at a log function, let's say log of x base b, whatever the base may be, as long as it's a base for a logarithm. Remember, you can only take the log of a positive number. So the domain means that in this case that x must be positive. So you can only take the log of a positive number. Okay? So when we find the domain, notice that regardless of what the base is, it doesn't matter what the base is, as long as it's a positive number and it's not equal to 1. Doesn't matter what the base is. The argument must be positive. It cannot be 0, so that's why you don't see an equal sign. It must be strictly greater than 0. So you set up an inequality like this, and you solve for x, and there's your domain. So my domain must be any real number greater than 8. Now they want you to write this in interval notation, so you're going to say parentheses 8 to infinity. Same thing here. So you can only take the log of a positive number, and so x plus 5 then must be positive, which means that x must be greater than negative 5. So my domain is negative 5 to infinity. Okay? All right, now number 2, you want to evaluate each expression without using a calculator. So that goes back to another worksheet that we did earlier with this, and that was section 4.2, part 1. Except here, though, you're dealing with common logarithms and natural logarithms as well. Okay, so that's where we started talking about common logarithms. Remember, common logarithm has base 10, and natural logarithm has base e. Okay, so what I would do here in part A, and let me go ahead and do that here. In part A, is I would think of it this way. So let's convert this to an exponential. So we have 10 to what power is 1,000, right? That's what that means. 10 to what power is 1,000? 10 to what power is 1,000? Well, the answer is, so that must be 10 cubed, right? 10 cubed is 1,000. Okay, part B, you have log of 10 to the 8th. All right. Now, what I would do here is I would think of this as now you learned of the property in 4.3, the properties of logarithms. Some more properties of logarithms where you could take the 8 and pull out in front, but we hadn't learned that in this section, so let's just not talk about that at this point. But what I want you to think about is this. So if I go ahead and write it like this, then let's convert that to an exponential. So you'd say the base is 10, so 10 to the box is equal to 10 to the 8th. Well, if I want this side to be 10 to the 8th, then this must be 10 to the 8th as well. So that means that this equals 8. Okay? So letter B is 8. All right. C, we have 10 raised to the log of 40 base 10. All right. So again, let's go ahead and let that equal box. Now notice though that the logarithm is in the exponent, so this is an exponential. Let's convert that to a logarithm. See, this right here was a log right here. So the first two were log. We wrote these as log equations, converted these to exponentials. Here, this is an exponential, so let's convert that to a log. So I'm going to say equal log. The base is 10, so that's understood to be 10. The exponent here goes here, and then box. So if I want this side to be log 40, then this has to also be log 40, so that must be 40. And remember, we learned a property that says that if the base of the logarithm that's in the exponent is the same as the base here, then it's just the argument. So that's 40. Letter D, you have the natural log of 1 equal, you want to find out what that equals? All right, let's convert that to an exponential. Remember the ln, the base is understood to be e, so you say e to the box equal 1. So e to the 0 is 1. So box must equal 0, right? All right. E, you have the natural log of e. Let's say equal box. All right, so the base of ln is e. So e to the box equal the argument e. So if I want this side to be e, and remember that's understood to be a 1 right here, then this must be 1 as well. So that must be equal 1. F, you have the natural log of e to the 12th. Okay, let's find out what that equals to. So e to the box equals e to the 12th. Well, if this side is e to the 12th, then this must be e to the 12th. So that's 12. All right. G, let's go ahead and do G right here. Now, the way you want to do G is you want to rewrite this 1 over e to the 5th power is e to the negative 5. So the natural log of e to negative 5 equal box. All right, that's the way you want to write this. And so e to the box equals e to negative 5. So I want this side to be e to the negative 5, then this must be e to the negative 5. So that must be equal negative 5. Okay. Over here, you have, let's do h right here. You have e to the natural log of 42 equal box. So that's kind of like let me see, like letter C. So you're going to say equal. Now see this base is e, right? So I'm going to write this, well, let's go ahead and do this. So log base e, correct? All right, which is ln, right? Which is ln. So I'm going to go ahead and do ln here. So e, so the exponent goes here, and the box goes here. So if I have the natural log of 42, then this must also be the natural log of 42. So that must equal 42. All right, so here, so this one is the same thing as that one, isn't it? So if the natural log of e to the 12th is 12, then the natural log of e to the 5x is also what? 5x. And then the reason is this, if you think about it. So let's go ahead and do I right here. So the natural log of e to the 5x equal box. So the ln, remember, has base, let me see if I wrote it right here. And remember, ln has base e. So e to the box equal e to the 5x. So if I want this side to be e to the 5x, then this must be e to the 5x. All right, this one is similar to the one we had here. All right, so in E, let me go ahead and do E right here. So over here we have e to the ln 6x equal box. So let's convert that to a logarithm. Now remember, this is going to be ln because my base is e. So I have natural log. So my exponent goes here, and then box. So if I want this side to be the natural log of 6x, then this box must be 6x. All right? And then 10, now the way, I'm sorry, k, the way you want to do k, and let me go ahead and do k in this little area here. So remember, you got to rewrite the radical. So the 5th root of x, the way you want to do that is you want to rewrite this as 10 log of x to the 1/5, okay? So remember, the 5th root of x means x to the 1/5 equal box. And so then this becomes equal log, since the base is 10, I'm just going to leave it as log, because remember that's understood to be base 10. And the exponent goes on this side, so log of x to the 1/2, right? And then box. So if the log of x to the 1/2 is on this side, then the log x to the 1/2 must be on this side. So this must be x to the 1/2, which is, I didn't mean 1/2, I mean 1/5, which is the 5th root of x. All right. Now, if you went ahead and you wrote it as x to the 1/5, that'll be fine, but we prefer the 5th root of x. Okay. All right. So I think that was the key to. I think we've done all the problems. So that's the key to worksheet 4.2, part 2.